Everyone. How did that go out of full screen mode? There we go. My name is Amy Wadle. I'm the Director of Concrete Pavements with Florida Concrete and Products Association. So I have over, I don't like to say the years anymore, but let's just say more than 20 years in the industry. And I have spent many of those years working and specifically looking at how concrete fits into sustainable construction practices. So I'm very happy to bring this topic to you all today. And today we're specifically going to be talking about concrete pavement. So who is Florida Concrete Products Association? I'm going to turn my camera off so that we can focus on the presentation now. Florida Concrete Products Association is an industry association of cement, concrete, aggregate, and associated industries, as well as we are the Florida chapter of the American Concrete Pavement Association, and we have concrete road contractors and their associated businesses that are also members. So I'd like to say a big thank you today to all of our members who make these webinars possible. There's a little delay in changing the slides. Well, it lets me change them. There we go. So we got a lot of different topics today. And for those of you who entered your AIA number, you will be receiving one learning unit in the health, safety, wellness category. And for our engineers on the webinar today, you will be eligible for one PDH, and a certificate will go out following the webinar. We're going to be talking about managing stormwater, both quality and quantity, reducing urban heat islands. We're going to be talking about safety in lighting and how that pavements play a role. We're going to be talking about resiliency and specifically in how flooding impacts pavements. And then we're going to talk about reducing embodied carbon in concrete pavements. So it's a lot of different topics today, and we're tying them all into how does concrete pavement affect people and planet when we're talking about the built environment. So let's get started with managing stormwater. And in case my video doesn't work, I have a photo on here as well. But I think the easiest way to start talking about pervious concrete is to see a little video and watch how quickly the water can pass through this pavement. I'm not sure if you can hear me while the video is running, and we'll just let this run for just a minute so you can see what's going on.
Yes, Amy, yes, we can hear you.
Okay, good. So this is coming out of the back of a ready-mix truck. That is a lot of water just disappearing into that pavement. So we're going to be talking about managing quantity and quality of stormwater. Okay, so now you get the picture. It's a little easier to talk about what is pervious concrete. It is a no fines concrete. It has about a 20% void space. It's missing the sand in the mix. So you just have your aggregates and your cement paste that are locking it together. And depending on the mix and how it's placed, you can take 300 to 1,000 inches per hour. And in a heavy afternoon rainstorm, you're getting what, an inch or two an hour. So really, the pavement layer is not your limiting factor. People are always worried about it getting clogged, but the pavement itself is really only part of the picture. So here you can see what it looks like, the texture, the traditional concrete on the right with a solid finish, and then the pervious concrete looking something like a Rice Krispie treat. So it's one way that we can reduce the impacts of development. And here you see showing pre-development where water can infiltrate through the soil and through grass, through the plants. And then when we develop a piece of property, we are really cutting off the way that water is getting back into the ground. So pervious concrete is one way that can really help us reduce the impacts of development. And as we saw, the pervious concrete layer, the pavement layer, the water can go directly through that really fast, but it has to go somewhere. So what we need to understand is that pervious concrete is not just a pavement, but it's a stormwater management system. It's important to have an aggregate reservoir underneath the pervious concrete to hold that water and to give it time to infiltrate down into the ground. So a geotextile fabric layer goes between the soil and the aggregate reservoir to keep the soil from migrating up in there and giving you less void space in the future. And as you can see here, you can mix that pervious concrete with asphalt, with concrete, with other types of pavement. And you want to make sure that you're going to have a barrier in between the other types of pavement and also the soil, because you could have washout underneath because that water is moving through so quickly. One other thing to keep in mind is, again, as the water's filtrating down into the soil, it still has to go somewhere. So this is important in certain parts of Florida where we have really high water tables. So we recommend that you have 24 inches between the base of your reservoir layer and the water table. And this helps it to function and for the water to get back down into the soil. You're also not going to compact the soil as much as you would with other types of pavement, because you want to make sure that you're keeping that filtration rate pretty good. And that's really going to be your limiting factor as to how fast the water gets into the soil. So we can calculate it. The pervious, 6 inches of pervious concrete with 20% void space, you're going to have 1.2 inches of rainfall that can be held in that layer, and a 6-inch aggregate base with a 40% void space is going to give you 2.4 inches for a total capacity to hold 3.6 inches of rainfall. Now we can extend that capacity by increasing the aggregate base layer. And then of course you have to calculate how quickly it will go into the soil. So we have some spreadsheets that can do this. It's really a pretty easy calculation. So you can also, add in rainfall that's coming into your pervious concrete from either traditional concrete or a roof area. So you can design your pervious concrete to store as much water as you need to for the conditions in that location. Additionally, you can reuse the water in that reservoir to water landscaping. We don't see this a lot in Florida because we're not a water scarce region, but we do in other parts of the country. This is really important for them to be able to capture and reuse that water. So what is the effect on your vegetation? What's important here is not only is the water getting through to the vegetation in your landscaping, it's also air. So sometimes we see in pavement where it's been popped up by roots, and those roots have been suffocated and they're trying to get up and get air. So the pervious concrete is going to let water and air down into the roots and help your trees be healthy. And also in a parking lot, you're able to pave within the drip line where you wouldn't be able to with an impervious surface. Also, there's a requirement for that first inch of rainfall to be captured and cleaned. And pervious concrete does fulfill those requirements. It's a best management practice for capturing anything dripping out of your vehicle or anything that gets spilled on a pavement. And it's cleaned in a couple of different ways. So there's actually some growth, algae or bacteria growth that happens in the void space, and that cleans the contaminants, as well as when it's getting into the soil, it gets broken down by the soil microbes. And we see this green picture on our right. Unfortunately, that is a reality at certain times of the year in certain areas. Now, pollution from parking lots, not necessarily the primary pollutant that's going into our waterways, but obviously we want to address all different types of pollution, as well as, fertilizers and other things. We want to keep the water coming off of our parking lots, which could be a large area. We want to keep that clean as well. So we've talked about recharging the groundwater, conserving our water resources, helping the vegetation that's surrounding our built environment, cleaning the runoff. And it's also a cooler surface, both due to the light color of the concrete, but also to the moisture that's in the pavement. And when that evaporates, it has a cooling effect. So there's a lot of environmental benefits when we're talking about pervious concrete. However, there's also economic benefits. So in places where land is cheap, we can buy more land and we can put in a retention pond. We know that the locations with inexpensive land is getting fewer, and our land costs are going up. So why not put that retention pond underneath of our parking lots and have more space on the lot to develop? So land cost is important, and also you're eliminating the infrastructure that's channeling the water into the retention pond. So the stormwater infrastructure can be significant depending on the project and the land cost. So these are two things to take into account. So great, that's some cool stuff. Now, where do we use it? Again, parking lots are really the ideal place to put pervious concrete. But you can also put it in driveways, sidewalks, residential streets, and it's a great product for roadway base as well as shoulders of the roadway to keep the runoff from going into an adjacent stream. Now, it isn't an application that you're going to use everywhere. It shouldn't be used for airports, runways, etc. Basketball courts. We're going to talk about ball courts a little more. Industrial facilities, gas stations, and again, areas with a high water table, you're going to lose the benefits of that water management. I like this example of a parking lot, and here they have chosen to mix both traditional concrete and pervious concrete. And they've designed it so that the reservoir is capturing the runoff from the impervious surface as well. And then you can also see that they have put in some swales that in an extreme event would capture the additional runoff. And as we just saw recently, we do have some extreme events with exceptional rainfall. Driveways, we're building on smaller and smaller lots with bigger and bigger houses. There are some municipalities that are taxing impervious surfaces, or they're simply not allowed. You have to keep a certain percent of your property as impervious. So a pervious driveway can really help in some of those situations. Sidewalks, pervious concrete is ADA compliant. You can use it in sidewalks. And the smaller the aggregate that you use in the mix, the smoother the surface. So for an application such as a road base, you're probably going to want to use a larger aggregate because the drainage is most important. Whereas a sidewalk, you're going to want to use a smaller aggregate to have a smoothest surface as possible. Streets and alleyways, residential street. There are a few developments where the homeowners really want to be as environmentally friendly as they possibly can, and this is one way to help reduce the impact of that new development. Again, pervious concrete, while it is a robust material, it is not having the same strength that you would need for an industrial facility, especially something like a port where you could have vehicles that would be even heavier than what you would find on the roadway. So this is not a product for an industrial facility. Now, I have an asterisk here because concrete is not for ball courts, but they make a great base for a court. You've seen after a tennis match that has a downpour and they're out there squeegeeing off the court so they can complete the match. If you have pervious concrete as the base of your ball court, following our afternoon thunderstorms, you're able to get right back out there on a dry court, and they make some covers that go on top with the nice colors and the lines. And I've seen a few of these projects recently, and then people are really happy to have that dry ball court. Okay, so we've talked about how to manage stormwater, both quantity and quality, and we're going to switch gears now to talk about safety. What we know is that no one really likes to park out in the back dark corner of a parking lot and go into a store. Where do we park? We park underneath the light. And the lighter color of concrete is reflective and will help give distribute the light more broadly throughout the parking lot. And this has been shown to not only reduce accidents, but also crime. And there even was one study that showed increased in shopping because people were more comfortable being there at night. I don't know about that, but we do know that it does improve the lighting in the parking lot. We also know that about half of the road fatalities occur at night, even though only 27% of the driving is done at night. Also, 75% of pedestrian fatalities occur at night. So you can combine to have that better lighting as well as the reflectivity off the roadway to make sure that you can have better visibility in driving at night. You can reduce your light fixtures, so you have some savings in the structure. Now, lighting has come a long way, so I don't know about the percentages anymore, but we do know that reflectivity is there. We're going to continue talking about reflectivity and urban heat islands. I took this picture in Fort Lauderdale in June, in the middle of the day, and you can see here that the concrete sidewalk was coming in at 132 degrees. And the aged asphalt that lightens up with age is 141 degrees. And then the newly resurfaced parking stalls is 152 degrees. So 10 to 20 degrees difference between your concrete and your asphalt. The Concrete Sustainability Hub at MIT has just come up with, published, I think it was last week, a study where they're talking about reflective pavements. And it's not as straightforward as just the change in the temperature of the pavement, because this reflection is also reflecting the light to the surrounding buildings and can actually heat up the buildings. So you have to look at the context and make sure that you're either providing vegetation in the right places or that it's not reflecting onto a building. So urban heat islands effect, I found, can be great up north in the wintertime. I had a colleague come in late to work and he said his car door was frozen shut and he couldn't open it. And I kind of laughed because I lived in the city and I didn't even have frost on my car. And that's when I really understood urban heat islands. It can be quite a difference between the city and the rural countryside. So here in Florida, of course, we're not really worried about how it affects, contributes to helping the heat in the wintertime. We're worried about cooling in the summertime. And the other thing to keep in mind is with every increase in temperature, the air is able to hold more moisture. And when it holds more moisture, it can also hold more pollution. So the higher the temperatures can have an effect on our air quality and having more polluted air. So this is something to think about when we're looking at pavements and surrounding buildings, and how can we keep from having heat waves and helping to reduce those incidents. Now, some cities actually have urban heat island ordinance. City of Miami is one of them. Now, the best way, of course, to address urban heat islands is through vegetation and trees, but we can't put them everywhere. So a combination of putting trees where you can to shade as much as possible, and then also lightening your pavement, the combined effect will give you your best results. Okay, and now we're going to talk about resiliency. Make sure we're all right on time. Okay. So resiliency is pretty broad, and there's different types of incidences, not just flooding, but fire and wind. So today, and we need to address resiliency in terms of buildings, in terms of operations. So we're really limiting today's discussion. We're going to talk about pavement resiliency in terms of flooding, because this is something that is a big impact here in Florida, where we have both sunny day flooding, and where we have high tides that actually come up above the street level. And then we also have rainfall events. So recently with Etta, we had up to 24 inches of rain in some places. So we have we have water coming up and water coming down. And what's even worse, and we saw this in Etta in some places, is when you have both at the same time. So we had some high tide events at the same time we were having extremely heavy rainfall events, and the water had nowhere to go. So it really exacerbated the situation. So when we're talking about pavement, we want to ask, how does these flooding events affect our pavements, and what can we do to make our pavement more resilient to these type of events? So when you're building a road, you're usually designing for a 20-year lifespan. Most roads are lasting much longer than that. The 20 years is where you're going to have to do some rehabilitation or some maintenance. And here, when we look at 20 years from now, in 2040, we're probably going to see somewhere in the range of 10 to 17 inches of sea level rise. So we need to make sure we're planning for those increased flooding events depending on the location of the project. Now, I want to clarify here, when we're talking about a flooding event, we're talking about an inundation. So pavement types can play a role in an inundation event. Now, when you have a washout type of flooding, it doesn't really matter what your pavement type is. You're going to have a road failure, and you can address that in other ways in the road base, in the environment surrounding the roadway to address the washout. So we're talking about an inundation event. We also are seeing increased call for resilient infrastructure. They haven't defined exactly what they mean by that, but what we know is that we need to prepare, and that we are likely going to see more funding tied to making sure that resiliency is taken into account. So what do we mean by pavement resiliency? So resiliency is the ability to resist, absorb, accommodate, and recover from an event in a timely manner. So what happens to the performance of the pavement? How long does it take to recover from that pavement? And what are the impacts to the pavement during that weakened condition? So we're going to go back a little bit to the fundamentals of how flexible pavement functions and a rigid pavement functions. In flexible pavement, that load is also reflected down into the base layers of that pavement structure, and they're important to carrying that load. You need to make sure that all the layers are to their design strengths to not have damage to your top pavement layer. And in a rigid pavement, it's less dependent on the base and the subgrade. It's more important that it has a uniform strength, because the weight of that load is carried across the slab. So here we can begin to see why it might be important that in a flooding event, those base layers are going to be weakened, and how is that going to affect the performance of those pavements. So I don't know if you all can see the teeny tiny writing here at the bottom, but you'll get a copy of the presentation. So this is a road that was having some maintenance done to it. It's US 441 in Alachua County, and there happened to be a flooding event. So they saw that the subgrade was reduced in strength, and decided to continue to follow and to see how quickly it recovered from the flooding event. And you can see the pre-flood levels. The resilience modulus was 17,000 PSI and had a significant drop. And it took up to a year. And we see the water recede off the pavement within a day or two, but it hasn't really recovered from the flooding event. And so these roads, as they continue to take traffic, it's reducing the ultimate lifespan of these roads, because they have the reduced load carrying capacity. So ideally, we would like to stay off the pavements until they dry out, but obviously that's not possible. So we're going to have primary impacts, which is during the flooding event, and then secondary impacts that can happen up to a year later, where you're having loaded pavements while they're still in that weakened condition. So we know we're going to bring in meals and water and rescue people. And sometimes these are even while the roadways are still flooded. We're also going to have debris removal. So a dump truck capacity is around 10 to 17 cubic yards of material. and 1 million cubic yards of debris is equal to about 65,000 dump trucks. So you can imagine that here in Mexico Beach, that this road was designed for typical traffic of a small town, was not necessarily designed to have several 100,000 additional heavy vehicles on it to remove all of this debris. And that doesn't even count the additional trucks that's going to come in for the reconstruction. Hurricane Irma, we had 4 million cubic yards in Miami-Dade, 3 million cubic yards of debris in Palm Beach. So these are just a few examples, and I imagine most people on the call are from Florida, and you may have unfortunately experienced some of this yourself. So I'm not going to go through too much more examples, just to understand that these local roads were not necessarily designed for heavy trucks and also in a weakened condition. Now, the Department of Transportation in Louisiana did a study following Katrina, and they took some satellite photos because they didn't have any pre-event values for their subgrade and their pavements. And they did some evaluation of where their pavements were flooded and where they had not been flooded. And they took samples from both their asphalt pavements and their concrete pavements. And they did find some significant damage to their asphalt pavements. And they had to rehabilitate about 200 miles of submerged roadways for about $15 million. And their concrete pavements really didn't see any strength loss, and they didn't have to do repairs. Australia has also had quite a few major flooding events and has researched their pavements, and also found rigid pavement is the more flood resilient pavement. And they have gone ahead and they've changed their design criteria so that they are now looking at designing roads with a weakened subgrade. And then they're prepared for that flooding event, and the pavement will withstand it regardless of what the type of pavement they put down. So what's our key performance measures? So what is the drop in performance? How quickly does it recover? And can it withstand loading in a weakened state? So we have found that the concrete will still perform with a weakened subgrade, and it will be quicker to recover, and it's less impacted by those secondary events. So we like to say stiffer pavements because there's different ways that you can address resilient pavements. You can stiffen the subgrade, you can use stabilized base, and you can use a stiffer pavement layer. And so we know concrete is one way to do that, but we want to say stiffer pavements are going to be more resilient to flooding. Let's check my time here. We're doing good. Okay. So if we're going to use concrete pavement, we would like to make that concrete as green as possible. So how do we reduce the embodied carbon in our concrete? And I meant to say this earlier, but you can be asking questions all along. We will take time for questions at the end, so you can type them into your sidebar as we go through these different topics. Sorry, I meant to say that at the beginning, but we will take time for your questions at the end. So how do we reduce embodied carbon? So again, I know there's a mix of people on this call. So for those of you in the industry, just bear with me as we go through the basics of embodied carbon and concrete mix. So our concrete mix is made up of cementitious materials, aggregates, both fine and coarse aggregates, water, and air. So we're going to focus on the cementitious materials, And we're focused on the cementitious materials because that is where 88% of the carbon emissions in concrete are coming from. Production of cement is an energy intensive process. Oh, I think it's okay. So here we see two different types of cement. We have Portland cement and Portland limestone cement. And the Portland limestone cement is going to have reduced CO2 by 10 to 12%. But when you're looking at the cement being 88% of the impact in a yard of concrete, you understand why it might be significant. Now, maybe you have heard of slag cement or fly ash, you're saying, wait a minute, they reduce the CO2 even more than that. Well, yes, they do, but they are not able to completely replace the Portland cement, and in some cases, they're not always readily available. So you're limited by the availability of slag and fly ash, as well as how much Portland cement can be replaced. So what's interesting about the Portland limestone cement is it can 100% replace the Portland cement. So what is Portland limestone cement? So traditional Portland cement already has about 5% limestone interground with the clinker. We're not going to go into cement production today, so just bear with me here. So the Portland limestone cement, you can replace up to 15%. So this is where your 10 to 12% lower CO2 emissions come from. So Portland limestone cement is ground a little bit finer, and so it has a little bit different properties, but it's very close to the same product and performs in a manner where you can replace 100% of your traditional Portland cement with the Portland limestone cement. So in Europe, this has been used for 50 some years. Their Portland limestone cement is their cement. They don't have the 5% that we have here. And they have different blends that go up to 35% limestone. Of course, those are not for all applications. And so here we've gone with a limit where it can really replace the traditional Portland cement. We also see that it's being accepted across the United States by DOTs and being used everywhere, including here in Florida. And we can anticipate that it will gradually be replacing traditional Portland cement. Again, it has a little different properties, and it has equivalent strength to our traditional Portland cement. And importantly, it works well with the supplementary cementitious materials like slag and fly ash. And here we can see some of the qualities in helping with workability and bleeding, and a little increase with heat of hydration, which we can address with the slag and the fly ash. And here we can see there's synergies between the Portland limestone cement and slag and fly ash. And, and you can see the different mix designs when if you can replace the ordinary Portland with the Portland limestone cement, you would be able to reduce all of these even more. So each one of these different types of mixes is going to come down by maybe another 10%. Like I said, we are using it here in Florida, and you likely have it on some of your projects. This is the Bayshore condominiums in Tampa, 18,000 cubic yards. where they had post-tension slabs that were 100% replaced with the limestone cement. And then for their shear walls and columns, they had 50% Portland limestone cement and 50% slag mix. The Fort DeSoto Bayway Bridge, it used type 1L, and this 10 is representing, so we said up to 15% of limestone. In this case, this particular cement had a 10% limestone in the mix, and they used 30% of their Portland limestone cement and 70% slag mix for the mass pours here to keep the heat of hydration down. Now, for those of you that work on LEED projects, all the different topics we've talked about today, they're going to help in your sustainable sites. Your pervious concrete is going to help with your rainwater management, your heat island reduction, as well as you can use it for the outdoor water use reduction. Traditional concrete or pervious is going to help with your heat island reduction. And then in materials and resources, we can use the lowered embodied energy and contributing to your life cycle impact reduction. And then I also want to make sure that you know there are environmental product declarations from the industry, both cement and concrete. There's industry average EPDs as well as company specific. And there's also sourcing of raw materials. There's a certificate for sustainably sourced concrete, as well as it's going to be a local material, and your slag and your fly ash are going to be recycled materials. The EPD database for the industry can be found on NRMCA, the National Ready Mix Concrete Association's website. Both the producer EPDs as well as industry EPDs, and these are third-party verified. Okay, so for those of you that are going, all right, that's nice, you told me some great things, but I know that on my projects, decisions are made based on cost, or and the others are these other factors are nice to have. So let's take just a minute and talk about cost and make sure that we understand, are we talking about construction cost? Are we talking about ownership cost? Are we talking about both? So we can help you analyze this. There's some software to kind of give you a quick look and compare asphalt and concrete. There are several different types of softwares out there to help you do this. This is just one of them. So you need some basic information about your project. You need to understand the soil conditions, and you need to know the traffic for the type of project that you're working on. So, and it's going to give you some preliminary design options with the cost associated with those. And this first graph here, this is in inches, and this is a parking lot example. And your concrete has a structural number of 2.25. This is important because often when we're comparing costs, we're looking at construction costs, and we're not comparing structurally equivalent options. So the asphalt this is your structurally equivalent option, and often what we see is an asphalt option that is you typically don't compare the cost of a Ford versus a Ferrari. You understand and you know that they're going to be different costs. But when it comes to pavement, often we're simply looking at this blue, which is the construction cost, and saying, well, the asphalt's cheaper, but they're not actually going to have the same load carrying capacity. Additionally, what we don't always think about when funding a project is the maintenance cost. So depending on the type of project and the owner, this may or may not be important to them. I foresee a project like schools. You know, they never have enough budget, and that maintenance cost, you know, if we could keep that maintenance cost down for our local municipalities, then they're going to be able to use that budget for other things. So yes, it's possible, not always, but often the concrete is going to have a little bit higher construction cost. But if you're looking at being the owner of this, there's a whole life of that payment important to you. And here you can see this blue line here is your concrete cost. Have to do a little bit of maintenance. And then your green and your red are the two different options for asphalt, where you see you're going to have to do some regular maintenance to that pavement. So this is just helping the owner to understand his choices and what the cost associated with those choices are. Florida Concrete and Products Association can help you with design, and this can be whether you're working on a parking lot, a roadway, a roundabout, any type of concrete pavement. We have experts in parking lots, we have experts in roadways and local roads, residential streets, highways. We can also help with questions about joint layout, or do you need dowel bars? We have, you can submit to the pavewise.com, say, hey, I got a project coming up and I want some more information, and we will be there to help you. The industry's offers this free design assistance, whether you need a lot of help or a little help or just have some questions. And that brings us to questions. So if you haven't already entered your questions as we went through these different topics, you can go here to the side and pop out this little panel and enter your questions. I'm going to have Roger come back on now and read the questions to me that you all have had. And I think we got about 10 minutes for questions. If we don't get through them all, then we will get back to you afterwards. So go ahead and enter your questions.
Hi, Amy. Yeah, we've got quite a few questions in already. We've got some questions from Jasmine. First of all, she says, good morning. Hi, Jasmine.
Good morning.
This is Jasmine, who is focused on transportation engineering at FAU. My question is in regard to the implementation of this type of concrete along highways for both sustainability and safety.
I'm going to guess here that your question, this type of concrete may be referring to pervious concrete. This has been studied by the University of Central Florida's Stormwater Management Academy, and they advocate for shoulders to help reduce the runoff from the roadway, as well as to keep the pollutants from the roadway from going into local waterways. So we don't see it used that often as shoulders of roads, but it's something that could be used.
I can add a little bit to that because out there in Oregon, they use pervious concrete for the bike lanes next to an asphalt roadway. So it is being used out there.
All right.
Next question is also from Jasmine. What is the approximate cost per square foot, and is it already being implemented by the FDOT?
I'm going to guess again about that we might be talking about pervious, and I believe that there are some parking lots that FDOT has used for the pervious concrete, which is the perfect application for pervious is a parking lot. It's a really good fit. I'm going to not give specific costs because there are a lot of variables that go into cost, and importantly is the infrastructure cost that you can do away with the stormwater infrastructure when you're using the pervious concrete. So there's a lot of different factors, and I know people hate that type of answer, but there's really a lot of variables for each project that have to be taken into account. And we would be happy to look at your specific project and to see where it can be advantageous and what factors are most important.
Another question, do you know if the majority of FDOT funded projects have chosen this type of concrete, or is it being implemented at a smaller percentage?
So what we see is there are a growing number of pervious concrete projects, not so much for FDOT because they're mostly doing roadways with heavy traffic, and this is not the ideal situation for pervious concrete. So where we see it is more in local municipalities and parking lots. We even see it in beach parking lots, the VA hospital in Palm Beach, alleyways in Delray Beach. They're currently putting in all their alleyways in pervious concrete to help mitigate the flooding. We also see in some areas pervious concrete being mandated surrounding the city wells because they want to make sure they're getting that water recharge. So as we continue to develop, that becomes a bigger and bigger issue to make sure the groundwater is being recharged. So not specifically with FDOT, but yes, we do see more pervious being used on private projects and public projects.
This is from Jasmine. Thank you again. It was an extremely interesting topic, and I would love to hear more.
All right, great. And as far as hearing more, I want to say that we touched on each of these different aspects a bit briefly today, and to kind of get a big picture of how pavement impacts our environment. So we go into more detail in other webinars, and some of them you can find on our YouTube channel. We have a webinar that goes into more detail on pervious concrete. We have one that goes into more detail on resiliency. And so we covered a lot of topics today. We go into a little more detail in some of these specifically, and you can find those on our YouTube channel.
Here's another comment from Jasmine. It doesn't let me unmute. So she would probably want to get in the conversation. So maybe we can contact her after this and talk to her.
Yeah, be glad to because we have a lot of people on the call today. The easiest way to manage all the questions is to just have a couple mics open. So I apologize for that. I really would love to meet you all in person and be able to talk to you one-on-one. We're just living with the times that we're in right now, and we'll be thankful when they're over.
Okay, could you discuss the maintenance of pervious concrete and how often does it need to be cleaned and who is typically responsible for the maintenance?
All right. So this is the most common question, and it's a great question. And yes, you do have to clean the pavement every now and then, and how often really depends on how much debris you're getting on the pavement. So we see a lot of landscaping companies here in Florida that are out and doing the landscaping every week, and they're blowing off the debris as they go. Now, if you don't have that on a weekly basis, then depending on how much debris is getting on your parking lot, you may want to have it to be swept or vacuumed. And there are some pavements out there that have not had any maintenance done for many, many years. And so they may no longer take 300 or 400 inches of water, but may be reduced down to even 5 or 6. But if your heavy afternoon thunderstorm is 1 inch per hour, that's not really the main problem, but we do recommend that you vacuum it regularly depending on how much debris. And the NRMCA has on their website a maintenance guide, and you can use that because there are some municipalities, when they're permitting this, they want to see your maintenance program, and you can use that to help create a maintenance program for your project. All right. Do we have
Okay,
more?
wait a second. Yeah, we have some more questions. Good morning. Is there a significant difference in the cost of construction and maintenance for pervious concretes and regular concretes?
So pervious concrete, if you're just talking about the pavement, it is going to be a little more expensive than your traditional concrete. However, what we see is when you're saving in the stormwater infrastructure far outweighs the cost of the material and the installation. And one important note here is when you're choosing a contractor for placing your pervious concrete, you want to make sure that they are a certified pervious concrete installer. The National Ready Mix Concrete Association issues a training, they give a training and they issue a certification, and they have a database, and there's quite a few here in Florida. But make sure that you're not just asking them if they know how to do pervious concrete. Ask them if they are certified. So there is some price difference, but you need to look at the cost holistically. So the pavement itself may be a little more, but typically people are saving money overall on the project from not having to put in the stormwater infrastructure.
What is the state of practice for preventing and clearing clogging in the pervious concrete?
You can use a pressure washer to clean it, as well as a vacuum truck. So the University of Central Florida Stormwater Management Academy, when they were studying pervious concrete, they had some test sections, and they came out there with a dump truck of dirt and put it on the pavement. They wet it, they drove over it, they really made sure it was the absolute worst condition that you could ever possibly imagine. And they came back and they vacuumed it off, and they sucked it up with a vacuum truck, and that pavement returned to 80% of its original capacity to infiltrate water. So yes, you can rehabilitate pervious pavement as long as it was installed properly in the first place with certified contractors. You can blow it off on a regular basis, you can pressure wash it, and you can vacuum it.
I think we have time for one more question, and this has to do, well, just let me read it. Can you provide the link to the presentation slides and the video on demand? And the comment is, great presentation, very important presentation by Amy Weddle. And can you provide her website, contact info, or email?
All right, yes. So we will be sending out an email that will include a link to the video and the presentation from today. And you have my email address here on this slide. You're welcome to send me an email, and I will follow up with you individually. And thank you everyone for participating today. It has been great. I appreciated all the questions, and I look forward to someday meeting you in person. So we've run out of time, and that is the end of the webinar, but we're going to leave this slide up for a few minutes. So if you didn't get your question in, you can still type in your questions and we will get back to you afterwards, or you can also send me an email. Thank you, everyone, and I wish you a great afternoon.